Now we're going to make an analysis of population pyramids. We have two population pyramids here from Afghanistan and Afghanistan again, but this one is in 2000, and this is a prediction of 2025, right? So as you can see, what is the difference between them? So we can see that there are more population. What kind of information can you find in a pyramid of population? First, you can see the amount of male and female, so the gender is the first one. Then the age of the people that is being analyzed. We have from 0 to 4, from 5 to 9, and then we have elderly people in this section, 80 and plus. So, and another thing that you can find information from this kind of pyramids is the category of the groups. From 0 to 10, they are considered child or young people. From 15 to 35, they're considered adults, and here they are considered, from depending of the country, from 55 65, they are considered the group of elderly people. Okay, so we have three kinds of categories: youngest, adults, and elderly people. So that is the expectation. As you can see in these two different pyramids, you can see that this one is wider. And are these numbers? Population in millions. So from 0 to 1 to 2. So in this case, Afghanistan has a population of about 2.1 million female and a population of 2.4 males, but just in this range from 0 to 4. Okay, what is the prediction from 2025? We are going to have like 3.8 or 9 female from 0 to 4 and a population of 0 to 4 million young kids from 0 to 4, and then is how you can analyze every single thing about this. Okay, as you can see here, for example, we have less male than female people related here, as you can see. Okay, so this is the demographic transition model. In the previous videos, you already saw this. Okay, so what is a demographic transition model? In a demographic transition model, we can see the birth rate, the death rate, the total population of this planet, because this is a world model. Okay, we have that in some cases when we have a population like this that is stable, is because we have the same rates of death and birth, as you can see here. That is the stage 1. In stage 2, we can see that the birth rate increase or is maintained and the death rate decrease. So we're having more births and less people is dying. And the total population, this line is increasing, as you can see. Then we have in stage 3 that in some countries the birth rate decrease and the death rate decrease, like a little or slightly, but the population is still increasing because they have like they are like equal. Okay, because as you can see, the death rate is less than this one. And then we have again like a fluctuation model in stage 4, in which there is no an exponential curve. There is more like something like an S curve. This is more like a J. And then when these two are so slow, birth rate and death rate, we're going to have a balance in how population is increasing. Okay, these are the 4 stages: stage 1, stage 2, stage 3, and stage 4. And depending of this kind of pyramids, you can see how that population is behaving depending of the country. We already do that, and then let me show you something else. Okay, we have human population models. We're going to continue from the last one that we were talking about, and that one was, let me search that one. Okay, this one. As the human population grows, increased stress is placed on all the Earth's systems. Why? Because if there is more people, we're going to need more food. The soil is going to need more nutrients to support that. We're going to need more water, timber, any kind of resources. So that causes stress to this planet, right? And that's why we have these two theories that we saw the last class, Malthusian and Bose-Rapp's theories, in which they say that if we don't have a system of agriculture that is going to provide food, the population cannot be stable, the population growth. So if we have more food, the population is going to increase rapidly, and that is like the theory, okay? Food resources is involved in that theory. Then we have that those are the resources that we are going to need, and suggest reasons why growing human populations require more water. Why do you think that people needs more water? That is part of the question to the evaluation, okay? You have to think, why do we need more water? One of the main reasons is because we need food. So water is used in agriculture to provide food. Also, if there is more people, we need more urbanized areas. And that means that we are going to have a water treatment plant. We are going to need fresh water to drink. So we need more water to survive. Then, what happens if the population increased? We're going to need more infrastructure. So, more transportation, more clean water, more shelter, and more wastes are going to be generated. Okay? This picture here is about regions of Africa, as you can see, East Africa, Middle Africa, West Africa, and Southern Africa, and we have the percentages of urban growth. As you can see, East Africa has not increased slightly. This one just a little bit, and it has been maintained. Why? Because in some of those countries they don't have access to this kind of infrastructure. So they are going to grow in a slower rate, okay? Also, if human population grows, the stress of the planet is going to increase. Why? Again, increasing resources use means more wastes, more production of CO2, more production of domestic wastes, and also there is going to be a release of industrial wastes in the effluents or the rivers, right? So there is going to be a discharge of some kind of pollution in the water systems and everything, in the atmosphere, in the rivers, in the soil. So everything is going to be affected. We are increasing and increasing in the rate that we are doing. Then we have again population pyramids, and again I'm going to show you what is divided in genders and age groups, as you can see. Show a cross-section of a population of a particular moment. How do you know that it's in a particular moment? Because it says here, a pyramid is going to show you the country, the year from that pyramid, the gender, the age of that population, and the categories that, as I told you, young people, adults, and elderly people. And also the mediums that you can see here and here. So you can make many analyses from this kind of models because they're going to be indicators to employ to quantify human population dynamics. Dynamics means change, how the population is changing, okay? A variety of models and indicators are employed to quantify human population dynamics. So what can you see? How population dynamic is going to be affected in a pyramid? Depending of the birth rate and the death rate. Birth rate, number of people that is being birthed, and death rate, the number of people that is dying, right? So birth rate is affected by existing age structure. If we have more young people that want to have kids, status of women in society, depending of the traditions. Now more people is working, women are working, so that is the thing. They don't want kids. Level of education, availability of family planning, provision of child benefit. And the death rate is being affected by existing age structure, availability of food and clean water, disease, war and conflict, and provision of health care. That is going to affect the death rate. Maybe it's going to increase, it's going to decrease, depending of these cases, okay? And we have METs and LETs. Just this thing to remember. What is a MET? What is a LET? METs are economically developed countries, and left are low economically developed countries. They are more industrialized. They have little or not industries. They have relative rich population, and they have population that is poor. They have access to education and health, limited access to education and health. So you know, because we have already talked about that. And then, to finish this class, I want you to make an analysis of this about, again, what can you see in a pyramid of population, okay?